Hey everyone, today we're going to discuss about graphing rational functions. Now, since we've learned how to obtain the asymptotes of a rational function in our previous video, today we are going to graph them. And asymptotes play a very important role in graphing rational functions. Now, in order for us to graph rational functions, we have to follow three steps. The first one is we have to obtain the vertical and horizontal asymptotes. Second is we obtain the oblique asymptotes, if any. And third, we construct a table of values whose values are to the left and right of the vertical asymptotes. So let's have our example here. F of x is equal to x minus 2 all over x plus 1. So the first thing that we have to do here is we have to get the vertical and the horizontal asymptotes. So vertical asymptote, we get the denominator and equate it to 0. So x plus 1 is equal to 0. Therefore, x is equal to negative 1. This is our vertical asymptote. For the horizontal asymptote, we check the degree. Since the degree of the numerator is 1, and the degree of the denominator is also 1, we know that n is equal to 1 and m is equal to 1. Therefore, n is equal to m. Now, since n is equal to m, then we would follow the condition where we'll get a sub n over b sub m. What does this mean? We get the coefficient of the highest exponent of the numerator and denominator. Since it's x here, that's where the highest exponent is, we get the coefficient. The coefficient of x is 1. And for the denominator, the coefficient of x here is also 1. If there's nothing written there, it's automatically 1. Since 1 divided by 1, this is equal to 1. Therefore, we get this, we equate it with y. So the horizontal asymptote is y equals 1. Okay, this time let's check for the oblique asymptotes. Remember that it should follow n is equal to m plus 1. Since n is 1, and m is also 1, we have 1 equals 1 plus 1. 1 plus 1 is 2, so 1 equals 2. Since this is not a true statement, then there are no oblique asymptotes. So, now we have these asymptotes x equals negative 1 and y equals 1. We're going to graph them first, then we'll construct a table of values around these values. Okay, so let's try to graph f of x is equal to x minus 2 all over x plus 1. We know that the vertical asymptote is x equals negative 1. So we get here the value of x, which is negative 1, and draw a vertical line like this, x equals negative 1. So that is our vertical asymptote. And in the same manner, we get y equals 1. Y is 1. So at this point, at y, then draw a horizontal line since it's the horizontal asymptote. Y equals 1. Take note that these asymptotes are not part of the graph. These are just guides so that we would know what is the part where the graph approaches but never reaches to. Now, what we're going to do is we are going to construct a table of values. Now, the table of values will center around the vertical asymptote. So we're going to have x equals negative 1. So this is our f of x. And this is our x. We're going to create 5 slots here. 1, 2, 3, 4, and 5. And what's in the middle is x equals negative 1. So you're going to center your table of values based on where your vertical asymptote is. There will always be a vertical asymptote, by the way. So negative 1 here, to the right of negative 1 are 0 and 1. And to the left of negative 1 is negative 2 and negative 3. So with that in mind, we're going to solve for the value of f of x with these values. Since we know that negative 1 is a vertical asymptote and negative 1 plus 1 is 0, the denominator becomes 0, then this value of f of x is undefined. Just remember that wherever the vertical asymptote is, the f of x is undefined. So we're just going to solve for negative 3. So for f of negative 3, we have the function is, let's remember that it is x plus 2. So this becomes negative 3 minus 2 all over negative 3 plus 1. Solve for that, we have negative 3 minus 2, that is negative 5. And negative 3 plus 1, that is negative 2. So negative 5 over 2. Simplify that, we get 5 halves. For f of negative 2, we have negative 2 minus 2 all over negative 2 plus 1. So that is negative 2 minus 2, that is negative 4. Negative 2 plus 1, that is negative 1. Negative 4 divided by negative 1 is 4. So you do the rest with f of 0 and f of 1. I'll leave it up to you, okay? So we're able to finish the table of values. You just have to substitute and solve for the value of y. That's just it. Now, let's plot these values and connect the values that we have. So if x is negative 3, then the value of y is 5 over 2, or that is 2.5. So it's somewhere here, negative 3 and 2.5. That's 5 over 2. To get 2.5, divide 5 and 2. If x is negative 2, then y is 4. Negative 2, then y is 4. So that's right here. Negative 1, that's undefined. It's the vertical asymptote. If x is 0, then y is negative 2. So let's go downwards a little bit. 0, that is negative 2. And if x is 1, then the value of f of x is negative 1/2. So it's right here. That's negative 0.5. Somewhere here. So we're just going to connect this, and we have the asymptote already. So take note that it approaches that part, so we can just draw it like this. Something like that. And we can just draw lines here to indicate that it's continuing and approaching that asymptote, but it never really reaches that asymptote. To confirm our answer, let's type in the actual graph. That's x minus 2 divided by x plus 1, which is close to what we originally obtained and passing through the original points that we just got. Take note that we cannot really perfectly draw the asymptote, the graph itself, but the answer is really close. So that's everything for graphing rational functions. I hope you learned a lot today, and see you guys on the next video.